Hello Physical Science, welcome back. This is Mr. B, and we are going to continue on with section 3, and we're going to talk about more of our groups, which again, remember, a group is a column on the periodic table. And remember from yesterday, the reason they're arranged in those groups is based off of the number of valence electrons that they have, which are the electrons in the outermost shell, are the highest energy level, and they're going to have similar properties in their within their groups, but they're not going to be identical because the location of the valence electrons changes as we move down the group. And so we mentioned the very reactive alkali metals in our last video. That was the only group we mentioned. So in this video we're going to take a look at 3 more groups, and they're going to contain elements that are more abundant actually naturally in the earth, because remember, the alkali metals are not found in nature anywhere because they are so reactive. So this video is going to mention some more abundant elements that kind of play more of a role in our lives. So we're moving to the right here, and we're now in the elements of group 2A, and they have a similar name to the ones in 1A, but they are alkaline instead of alkali. So alkaline earth metals, and all these alkaline earth metals have 2 valence electrons, and most of the metals that are in group 2A are harder than the metals in group 1A, so that's one difference as we move from left to right here. And the melting point of magnesium, which is one of those alkaline earth metals, is 650 degrees Celsius, which is much higher than the melting point of sodium, which is only 98 degrees Celsius. So that's just kind of a little introduction into some of the differences as we're moving from left to right here, and we're going to get even more differences with this slide right here. And there are differences in reactivity among the alkaline earth metals that are shown by the way they react with water. So remember in the video we watched all the violent reactions that occurred with water. This one for the alkaline earth metals is going to be much different than the alkali metals. First off, there's calcium, strontium, and barium. They react easily with cold water. So if you put them in cold water, they will react. Magnesium, however, on the other hand, will react with hot water, but it will not react with cold water. And then no reaction will occur when beryllium is added to water. So maybe in class I might have you do a little investigation, maybe figure out why that is. Why would some of them only react with cold water? Why would some react with hot water? And why would one not react with water at all? So maybe be thinking about that in the back of your head, and maybe do a little research even before class could help you out. But I have a feeling in class I'm going to have you research why this is actually the case, because it is pretty interesting. And so now we're going to take a look at actually some examples of different elements that are found in the alkaline earth metal group, and how they kind of maybe play a role in everyday life, because that's what a lot of these elements do. So our first one is magnesium, and they play a key role in photosynthesis. So hopefully you know what photosynthesis is. It's the process that plants do to basically convert the energy in sun. And they take in water and CO2 as well to release oxygen and create their own food. So the compound at the center of this process is known as chlorophyll. Hopefully, again, if you don't know that, you'll know that next year in biology. And at the center of chlorophyll is a magnesium atom. So magnesium is a key role in something that we benefit from every single day, because without photosynthesis we would not have the oxygen necessary for us to survive. And another use for magnesium is that a mixture of it and other metals can be as strong as steel but much lighter. So the frames of bicycles and backpacks often contain magnesium. So again, that might be another role in your life, that if you maybe ride your bike around a lot, that you might have some magnesium helping you out there, so you don't have to lug around a really heavy bike everywhere. So another really important element found in the alkaline earth metals is calcium. So calcium carbonate, which is a compound of calcium, carbon, and oxygen, is the main ingredient in chalk, limestone, and coral. And your toothpaste may contain the compound calcium carbonate, because this hard substance can actually polish your teeth. So that might be something that you might not have known before. And magnesium and calcium have essential biological functions, and they provide materials that's used in construction and transportation. So these are 2 extremely important elements, not just in terms of the periodic table, but in terms of life in general, biology, and also in the kind of the manufacturing world as well. So Again, that's why one of the reasons why we need to learn about this stuff, because it is important and actually does apply to our everyday life. And so then this is just a recap of the alkaline earth metals. So chlorophyll molecules in spinach contain magnesium. An oyster shell and a pearl are both made from calcium carbonate. And a plaster cast, which hopefully none of you have had to wear these too much, but I imagine you've probably had to wear a cast at some point in your life, contains the compound calcium sulfate, which is again calcium found right here in group 2A of our alkaline earth metals. So those two are probably the most important in that group. So now we're going to move on to the next group. It's group 3A, and it is known as the boron family, so I'd make sure I wrote this down. And it contains the metalloid boron, and this most famous member of this group is actually going to be aluminum, so I would make sure to write that down. I have a feeling I might ask what the most famous member of the boron family is, and it's definitely going to be aluminum. And then there are three less familiar metals, gallium, indium, and thallium. And all these elements are going to have 3 valence electrons, and that makes sense because we know group 3A, so this is our number of valence electrons that we have. And so now we're going to learn a little bit more about aluminum. You probably know a couple uses of aluminum, but we're going to get into some more in depth on this as well. So aluminum is actually the most abundant metal in Earth's crust. So hopefully you've learned about the layers of the Earth, the crust, the mantle, the core. So in the crust, the most abundant metal we're going to find is aluminum. And make sure you realize we say metal and not the most abundant element in general. But of all the metals, which there is a lot of them, aluminum is the most abundant. And just some characteristics here of aluminum that kind of make it probably one of the most readily used metals that we have is that it is less reactive than sodium and magnesium, so it's not going to create a giant explosion every time it's exposed to the water or the air. It is strong, it's lightweight, and it's malleable. So those are some really good characteristics when we talk about wanting to make something useful. It's strong, it's lightweight, and we can actually bend it into the shape that we want. So those are some other good characteristics. And it's also a good conductor of an electric current. So aluminum has a lot of really beneficial properties that make it very widely used in a lot of different things. And I might have, okay, yep, so a compound of boron, silicon, and oxygen is used to make the glass that does not shatter easily when its temperature changes rapidly. So sorry, I was kind of jumping around there. So this is kind of some examples of some of the other things, of the other groups, boron. Okay, sorry, let me start over. So now, boron, so it's called the boron family, so they're going to talk about what it is used for as well. So when they combine boron with silicon and oxygen, it's used to make glass that does not shatter easily when temperature changes rapidly. So glass that contains boron is used to make laboratory glassware and cookware that can go directly from the oven to the refrigerator. So again, sorry about that, I got a little lost there, but again, if you ever are do much cooking, or if working with the lab equipment in the chemistry classroom, that is most likely going to have boron in it, because if it did not, it would shatter too easily if the temperature changes, and that is one of the useful, useful uses of boron. So, and we'll probably dive more into aluminum. I thought this presentation had more about aluminum, but we'll probably dive more into aluminum in class. And we have one more family for this video, and that is the carbon family. So group 4A contains a nonmetal, carbon, 2 metalloids, silicon and germanium, and 2 metals, tin and lead. And each of these elements has 4 valence electrons, group 4A. And notice that the metallic nature of the elements increases from top to bottom within the group. Germanium is a better conductor of electric current than silicon. So for this group, as we start from the top and move to the bottom, we're going to get more metallic. And so hopefully you've heard of carbon before, so we're going to focus on carbon because it is one of the most important elements, because except for water, most of the compounds in your body contain carbon. So we are what we call carbon-based life forms, meaning that we are made up of a lot of carbon, and life on Earth would not exist without carbon. So that's really how important it is. Reactions that occur in the cells of your body are controlled by carbon compounds. So carbon, cannot stress the importance. There's a whole section of chemistry known as organic chemistry, which focuses almost solely on how carbon reacts and with basically everything else. So carbon is extremely important, And so, not to leave some of the other ones out, again, we'll probably dive more into carbon and aluminum in class. And to wrap this video up, we're going to talk about another member of the carbon family, which is silicon, and it's the second most abundant element in Earth's crust, behind aluminum. Oh, I'm sorry, most abundant element, not even metal, most abundant element. And the clay used to produce this pottery contains silicon compounds that are known as silicates. So we're going to dive more into those in class and maybe help them make a little more sense. But if you have any questions, make sure you let me know.